Good afternoon, everyone. So we are from Upscale AI. Myself, Ramana Dasari, and my colleague Omar Ramanathan. So today we are going to talk about SONiC as a management plane in UALink. So let's look at the agenda for today. The first thing is we should understand why are you looking for the UALink, and this, subsequently we will look at who are the members of this open consortium, and we will try to touch upon something on the UALink, basic architecture, and then the switch, and then the management plane that is present in the UALink. And we will also look at the configuration aspects of the UALink, like switch management agent, pod controller, and at the end we will go for a call to action. Yeah, let's look at why are we looking for an UALink. By the way, UALink is ultra accelerator link, so which is used for the high-speed interconnects between the accelerators. If you look at the current AI models, they are pushing the boundaries of the interconnect. So the interconnects are also going, but they are vendor locked. So the UALink offers a vendor neutral, open, scalable fabric that is designed for the AI scale performance. So if you the key innovations that are part of the UALink are the memory fabric based semantics. For example, the load store semantics that we have for the AI workloads. Yeah, as you are aware of it, you can look at it. So there are some promoter members as part of the consortiums, and we have all the hyperscalers and then the big vendors, and we have the contributor members as well. So UALink they have released a spec in 1.0 during April timeframe. So let's look at what is a UALink. Basically, it's a protocols and the interfaces that are used to interact with the accelerators together through a fabric called UALink switch. So basically, these enable the low latency, high bandwidth communication across these accelerators, which is needed for any of the AI jobs that are being done today. So the communication that can happen between the accelerators, it can be within a single OS domain. When we say OS domain, it's a system node. It's in a single system node. There could be multiple GPUs which are trying to communicate together to achieve an end goal, or it could be across the OS domains or across the system nodes where they are trying to talk to the multiple accelerators and then trying to finish the job. So you can look at here, there is a rack system, and then there is a OS domain, single OS domain connections which are trying to talk to each other. So in a rack system, there are multiple accelerators which are being managed, accelerators and also switches which are being managed by a central entity called pod controller. A pod is basically, it's a collection of the accelerators and switches connected through an UALink fabric. So generally the pods are being segregated into another logical entities called virtual pods, and these can be used by the tenants to achieve their end agentic jobs. Yeah, at a high level, how is the UALink architecture is looking like? Basically, it's a layered protocol stack architecture. At the top layer, UAL protocol layer, which is trying to talk in terms of the messages, for example, the reads and writes across the accelerators, and these messages are being packetized, or they are being packed into fleets, and then these fleets are transmitted over an Ethernet interface, Ethernet physical layer. So when two accelerators are trying to talk each other, so when they are sending the packets, there should be an entity which is actually trying to send to the other guy. So the switch is the entity which is trying to receive the packets and then trying to route those packets to a destination accelerator, to either for reading the memory from the destination accelerators or the writing the memory data into the destination accelerator memory, so that all the AI related jobs are going to be achieved using these communications. And basically there should be a route which is actually trying to allow the communication between a source accelerator to a destination accelerator. So that is what we can see there. So this route is going to be compressed of a source port and the destination accelerator ID. And when we do a route lookup, it is going to give us the destination port on which the destination accelerator is reachable. So the route identifier is the destination identifier is a 10-bit value. So essentially it is indicating that we can connect the 1024 accelerators together using this the high-speed fabric. So currently the UALink switch supports only the unicast messages. That means like one accelerator can talk to the other accelerator, but not in a multicast fashion. So as we saw earlier, you can logically segregate the accelerators and then switches together and create one virtual pod. And this virtual pod gives us the benefit of multi-tenancy, where the one tenant who is trying to run his AA job can use this virtual pod to achieve his functionality. And like that, we can support multiple tenants at the same time by using this virtualization concept. Yeah, from here I'll hand over to my colleague Uma to take over the management aspects. Thank you.
Hi. This is the management architecture. So pod controller that you see here is the main component. So it is responsible for managing the resources in the pod. So resources in the pod, namely the switch and the accelerator. So a pod controller as listed here is responsible for initialization and then workload management, generically config push, synchronization of configuration, and it's telemetry as well. So even status and operational status can be synced up with the pod controller. So the northbound of the pod controller is REST API and GUI. You can even connect to, say, a tool like Grafana, which visualizes through a time series database. Or you can connect it to an AI/ML tool that actually gets the feedback, and with the feedback, it can take actions, mainly by looking at and analyzing all the telemetry data. So the pod controller on the southbound side is, so as mentioned, it talks to the switch and the accelerators. So it doesn't talk directly, but through agents. And there is a switch management agent that runs as part of the switch, and a node management agent that runs as part of the accelerator. Now further, if you see this picture here, the pod controller talks to the switch management agent through GNMI, and I'll talk more about it in the next slide. And on the switch management's southbound APIs, it's basically UALink SI APIs, which are extension of the current SI APIs. Now, we're not going to concentrate more further on this node management agent. So let me go to the next slide. Yeah. So we use, so as mentioned earlier about SMA, so we use SONiC to host SMA. And why SONiC? For all the reasons that we all know. It's open, containerized, vendor agnostic, and moreover, it gives the flexibility to use any kind of pod controller. So, and the SI APIs as well. So we already have a big set of SI APIs. So we need to extend it to support the new APIs that it comes as part of the UALink specification. So it has tons of, logging is mature enough, and then there's telemetry as well. So telemetry also requires some changes that's as part of the next slide. And it's well known that we have a very strong community, and it's growing by the day. So So here, this is a representative image. It's not from the actual design because the spec is just a couple of months old. There's a daemon, a SMA daemon, running as part of a separate container, and is isolated, and it handles all the GNMI and the GNOI. So GNMI for configuration and telemetry and control that that comes as part of this UALink specification. And so that populates the Redis DB, and thereafter the ORC agent would be able to receive this notification through, say, SMA Manager D, and that would in turn populate the ASIC DB, and that we all know the sync D receives it, and thereafter we have a new set of SAI APIs, that is the UALink SAI APIs that comes as part of the libSAI SO that will be newly published. And again, a new set of new SDK, that is a UALink SDK would be provided. Along with the ASIC drivers, there will also be UALink drivers. There will also be changes in the platform infra. Okay. So, as the expectation is the SMA hosts the GNMI server in the dial-in mode. So the GNMI client would be running in the pod controller, and the regular set like get, set, capability, subscribe will be supported. But along with that, the specification talks about control. So as part of the control, it's mainly responsible for orchestration of the SMA and some amount of configuration push, sync, and operational state updates, and then route programming. Moreover, it gives feedback for every step. To say, compared to the regular set get, it is bidirectional, and it gives updates from both the agent and the server, that say a particular synchronization or some kind of phase is complete, it would indicate to the other end. Yeah, finally, call to action. So we are working on the following areas, and we would like collaboration. So first of all, we need to integrate the SAI APIs according to the new specification, that is the 200G 1.0 UALink specification. And then we need to develop the switch management agent, whose interface is to call the UALink SAI APIs. And on the northbound side of SMA, we also have this GNMI interfaces. So we need to add the new set of, we need to bring in the this new set of GNMI, that is the control APIs and so on. This is for the pod integration. And we need to now support telemetry and congestion management for AI workloads, specifically for scale-up networks. We need to validate SONiC with UALink enabled AI clusters and switches, so, and publish the results as well. Yeah. Thank you.
Yeah, we will be needing a support from the industry as well, all the collaborators, the switch vendors who are going to work on this area in pushing the new SAI objects for the UALink SAI. And yeah, this forum should be a good one to collaborate all the people over here in the UALink. Yeah, thank you. Please go ahead.
Hello, this is Ryan from Next Hop again. Is there an existing work group that covers the UALink improvements in SONiC today?
There is a scale-up work group that's already present.
Okay, great.
Some work is going on.
Great. Thanks.
Yeah, I have a question.
Yeah, go ahead.
I am Chintan from Broadcom. Why are we not leveraging the existing Ethernet technology that we have for scale-up? I mean, I would want to understand what is that additional benefits that UALink brings to the table, which the existing Ethernet cannot deliver.
The Ethernet comes with a lot of the legacy background, and if you look at the UALink, right? So it is direct memory semantics based approach where you directly go and read it and write it into those memories. So whereas in Ethernet, you need to transport those anything that you wanted to access from the peer accelerator, you need to transport over an Ethernet network, and the latencies are very critical when we are trying to do the load speed, high bandwidth communications. They have to be directly connected, and that's where we are looking at the memory semantics based approach. It's not that Ethernet cannot solve it, but we have to overcome some of the limitations that are present today in a legacy Ethernet.
So what is the latency that you intend to deliver with UALink?
With all the end-to-end latency, we were thinking in around less than 200 nanoseconds or to 200 nanoseconds.
Okay.
Yeah, thank you.
Hey, this is Ravi. Hi, this is Ravi from Marvel.
Yeah, hi,
Nice
Ravi.
talk. One small correction, I think. UALink is coming up with a completely new SI. It's not an extension to the OCP SI.
That's right.
Yeah, and then given that, right, given it's completely new SI, do we need to have a different kind of sync D instead of just having what is the picture you showed was existing sync D calling UALink SI APIs, right? Should it be a completely different sync D? That was one question. And the other question is, what do we do about a lot of things that are not needed in an UALink switch? For example, we don't need your FRR to be
Right.
running. So what do we do for all this? What is the plan?
Since SONiC is, maybe I'll ask the second question first and then we'll go to the first question. Since SONiC is a containerized and modular based approach, right? Whichever things that are needed for an UALink world, we don't need to include all of them, and then we will include what are required for only the UALink switch management. So the first one is, yeah, so there is as we saw earlier, there is a switch management agent which is actually trying to configure all the UALink related configurations. So that's the new agent that is going to be embedded into the SONiC, and then he's going to take care of all the configurations. I'll ask Kumar to add more content to it.
Yeah, so when you say extension, it doesn't mean that it extends this APIs. The meaning here is we have a lot of infra in place, so it's going to be easier to add the new set of UALink APIs. Yeah, potentially there could be a new SyncD as well. How much of it we can leverage, we need to see.
Yeah, for example, right, to answer both of your questions, right, just to answer, for example, today, a lot of control plane APIs, there are no containers, nothing, right? Control plane APIs come in directly as part of your ARC agent calling in, right?
Right.
And UALink doesn't have any of those control planes. So there are some fundamental things that need to be addressed in SONiC for all
Yeah.
this to happen, right?
Yeah.
So I'm just trying to see,
Yeah,
has this been thought about?
Yeah, on those lines, you're right. It's not a control plane here. It's completely management plane because completely driven by the pod controller. So a
Yeah.
lot of the control plane components would probably not be needed.
Yeah. So you will be start looking at it later, or do you need community to look at?
Yeah, it's too
Yeah,
early.
so you don't require a lot of configuration like Ethernet world here, right? It's just one routing table and then some of the port configurations and then one queue mapping configurations. So the number of configurations are less in the UL world, but yeah, so the SMA is a specialized agent that is going to be used in the UALink world compared to the normal configurations that are going to come in a regular SONiC world.
Yeah, the point is, right, the existing, completely the routes are completely different in UALink versus what we are talking about in existing SONiC, right?
Right.
And the ARC agent has to be redesigned, or at least has to be modularized to remove a lot of things that it statically does that in it. So I think that will be the fundamental work in getting
Exactly,
working.
yeah, that needs to be done.
Yeah,
Yeah,
okay.
thank you.
Thanks.
Do we have more questions? Anyone? Oh,
Yeah, go ahead.
So this is within a rack.
Yeah.
Can this be used to connect two racks?
Yes, a single pod controller can control the multiple racks as well. So if you look at that rack diagram that we have shown, if we are going any communication across the racks, there is a scale out switch on top of it, and then using that we can communicate across the two racks as well. But a single pod controller can manage both of these racks.
Does this really has any limitation on the length of the across the length?
Right now, we have total accelerators are 1024, but in terms of the length, I believe there is a limitation. But we can answer. Thank you.
Cool. Any more question? If not, thanks a lot for the presentation.
Thanks, Shashi. Thank you, guys.